Hello, everyone. Welcome to this session on open source big data and Java. My name is Pratik Patel. I'm a Java champion based out of Atlanta and also a developer advocate at Azul. You can follow me on Twitter at @PrPatel for any follow-up questions or any conversation you wish to have about this presentation or about the JVM or Java in general. So I work at a company called Azul Systems, and in my opinion, we make the best JVM in the galaxy. You can find open source OpenJDK Azul builds, which are free and get support for, or you can step up to the Azul Platform Prime, which is our high performance JDK for running big data infrastructure, like the things that we're going to talk about in this presentation. So for example, Azul Platform Prime outperforms OpenJDK by 37% on the Java Renaissance test suite. So it's worth checking out. And of course, it's just a JDK, so there's no code changes that you need to do to use our high performance or open source build of the OpenJDK. And also check out this nice community portal called fujay.io, where there are lots of different content and article pieces on Java and the Java ecosystem. So let's get into our presentation and talk about open source big data projects. First, we're going to spend a couple of minutes talking about what is big data? What does that actually mean? And we'll talk about why Java is especially well suited for big data projects. And then we'll dive in and look at some interesting big data projects in the time that we have. All right, so let's very quickly, since we have a short schedule here today, talk about what is big data. Now, big data in general is data processing at scale. What does that actually mean? All right. So there's the original 3 V's that define big data: volume, velocity, and variety. And since the original definition of big data, there have been numerous other things which have come in that help define what a big data project or what big data software looks like. Exhaustivity, fine-grained, relationality, as well as extensionality, veracity, value, and variability. So big data projects are projects which are done at scale. And if you go to this link here on this slide, which you'll have access to after this presentation, you can see what those different terms mean. For example, volume, most people understand: a huge amount of data, terabytes, petabytes of data. Velocity, things which are data which is created very quickly or in real time. Variety being structured, semi-structured, or unstructured data. It can qualify as big data. And then there's the other things like we talked about, like exhaustivity and veracity and other things like that. You can look at these definitions and you can decide if what you're working on would really be described as a big data project. But you probably already know what your project is, if it's a big data project or not. If it's very large, and you have data that's constantly coming in or getting updated, and you're able to get insights from that data, and you can go and scale the data that you're using to get even more and more data as part of your big data project, you know you're running a big data project. Okay, so some of the other ways I like to think about it is, if you're running a big data project, you typically have multiple servers or processes or data stores that span all of the data that you need. And you have to do some kind of distributing processing to be able to run your big data projects. And of course, this is not stuff that runs on your laptop. This is something you have to deploy onto cloud servers, or if you have an in-house infrastructure, you would deploy it onto a cluster of servers on your in-house infrastructure. Okay, let's move on to the next question. Why does big data run on Java? Now, this is a great question, right? One that may not be asked very often, but I will answer it for you anyways. Java is fast because of the industry-leading Java virtual machine. Of course, big data projects, many of which are near real-time or even real-time, need a platform that is extremely performant, fast, and efficient, right? And another reason why a lot of big data projects are written in Java is because of OpenJDK. OpenJDK is an open source platform which anybody can use to build out these projects, and something that's been around for over 25 years, and it's proven and reliable and all the other things we said already, right? And another reason is because Java is simple to program compared to C or C++, or even Go for that matter, because it's a garbage collected platform. So you don't have to do all the low-level mechanics with working with something like a C or C++ programming environment where you have to do memory management yourself. And of course, we all know of all the great things which are in the Java language, especially in the recent versions of Java since Java 8, with things like records coming into play, the updates to the way garbage collection is done, as well as new features for streams and other things like that. So it's a really nice language to program in, which is fast and efficient and scalable. Okay, so you may have also noticed, and you probably will definitely notice during this presentation, that the big data projects we'll talk about here are all hosted at the Apache Foundation. Well, not all of them are hosted at the Apache Foundation, but a lot of them are hosted at the Apache Foundation. Why are they all hosted there? I have no idea what the answer to that is, but it's great that all these places have all these projects have a place where they can live and they can be open source under the Apache public license, which, as you know, is a liberal, business-friendly license. All right, so if we go have a look under the big data category on the apache.org website, you'll see that these are all the big data projects that are out there. We'll talk about a few of these today. We'll talk, for example, about Apache Cassandra, Apache Kafka. We'll also get a little bit into Airflow to give you an idea of what all these different types of projects do. Well, unfortunately, we don't have time in 30 minutes to cover even a small number of these. So we'll just try to do as many as we can. So the first one I want to talk about is Apache Cassandra. Now, this project has been around for a while, I think since about 2008. It actually came out of Facebook because they needed something that would allow them to do analytics and processing at scale. So technically, Cassandra is not a big data project, at least the way it's categorized on the apache.org website. It's under the database category. However, you'll find if you look around that lots and lots of things build on top of Cassandra for their big data project, and specifically their big data project stores. So let's have a quick look and get an idea of what Apache Cassandra is and see if it's something that you might want to use for your big data projects, or some feature that you're developing, or any other kinds of things that you might be doing inside your company. So what is Cassandra? Cassandra is a wide column store. The technical definition of it, but if we dig deeper, it's essentially a two-dimensional key value store. It is also categorized as NoSQL, and it does things for you like sharding and data partitioning, which allow you to have massive scale for your data that you put into a Cassandra store. Okay, it also gives you linear scalability and fault tolerance. That means you can replicate your Cassandra deployment across multiple servers and even across multiple data centers, so you get fault tolerance and resiliency. So in case a server goes down, or even a whole data center goes down, you don't have to worry that you don't have access to that data, because the data can automatically be replicated in Cassandra across multiple regions. And of course, with big data projects, you need to have fast read and write, and Cassandra supports that. Now, remember, in NoSQL, Cassandra is not SQL. It is a NoSQL type of project, so it doesn't really have concept of relations. And also, columns can vary from row to row within the same key store. Right? So this is not something that you might be used to if you're working in standard SQL, whether you're using Postgres, MySQL, Oracle, whatever. So it's something to be aware of when you're looking at Cassandra for building out a foundation for your big data project. So what does actually working with Cassandra looks like? Let's have a couple of quick examples and then we'll move forward. So first, with Cassandra, you create a key store and then you can create a table inside of it, like so. You can say users by email has email, which is text, a country, first name, age, which is an int, and then you can set a single or composite primary key of those things. And that's how you make lookups in Cassandra go very, very fast, by creating those primary keys which zero in on the exact way that you will be getting information out of that Cassandra data store. How do you insert stuff into this? Insert into, and you can see some of the examples here, right? If you look at this, you'll see that it looks very much like SQL, but it's not SQL. There's some small differences and some big differences when working with Cassandra. So something to be aware of, and I wanted to give you an idea of what it actually looks like. And again, if you go to the URL at the bottom of this slide, you'll be able to dive into a beginner tutorial that will help you understand what working with Cassandra looks like and step you through a very basic tutorial to get started. All right, so the next thing I want to talk about is Apache Spark. Now, Apache Spark is a project that has also been around for a long time and is kind of a successor to Apache Hadoop. We'll talk about that in just a minute as to how they're a little bit different. But Apache Spark is the state of the art currently for doing processing and analyzing of data. It is essentially a unified analytics engine, and it does run in memory. So you do need quite a bit of memory. But with Spark, you can code your application that runs in Spark using Java, Scala, Kotlin, or even Python. So Spark is actually very flexible. Most people write Spark code in either Java or in Scala, but you can also use Kotlin with some of the newer libraries which are out, or even Python if you want to. Okay, and what does Spark do at kind of its core? It can do stream processing, so you can ingest data, manipulate it, store it, and then pass it on to something else if you want to. But typically you would do some manipulation inside of a Spark cluster and get streams of information in and have it ready for doing graph analytics or doing machine learning against. So there's lots and lots of things that you can do with Spark. You define different objects or data frames that you store the data, and then you can manipulate that data or run analysis against that data. And it is extremely fast. I would say almost real time, definitely near real time. And so when I say fast, I mentioned Apache Hadoop before. And the reason why it's 100 times faster than Hadoop is not just because of the distributed architecture of Apache Spark, but Apache Spark, the data is held in memory, as opposed to Hadoop, where the data is on disk. So that obviously tells you that it's going to be much faster just because of that. But also Apache Spark's Apache Spark's architecture is such that it's able to do that distributed type of processing very efficiently, and it can figure out how to distribute your processing workloads across multiple servers, multiple instances. And it also gives you the ability to go in and specify how you want stuff processed in a cluster once you get to that level of sophistication. Okay. But remember, you need lots and lots of memory. Essentially, you need to hold most, if not all, of your data inside of memory when you're running Apache Spark. But fortunately, nowadays, memory is not super expensive like it used to be. Of course, memory is much more expensive than disk. So what some projects do is they will load up data into Apache Spark from a HDFS or Hadoop file system, right? And you can also get data into Spark in other ways, which we'll talk about when we look at some of the other big data projects. Right? And one thing that makes Spark very, very fast is that things can be easily parallelized when you need to do data transformation or when you need to do data processing, right? And let's have a quick example of how you would do something like that. So you can see in this case, on the first line, we load up a very large text file, which is in the Hadoop file system format. And then we write some code to get the counts of all the different numbers. So we're basically reading through this text file and we're creating a tuple, essentially key value pair of a word and the number of times a word appears in this text file. So we do a flat map, we split it on a space, and then we map those to a pair. And every time we see that new, every time we see a word, again, we basically add to that word count, right? And then the last line on this goes and saves it to an HDFS so that we can quickly load that data if we're not going to use it for something right now. And here's a little bit more of a math kind of algorithmic example where we want to parallelize the processing of a list of vectors, which is going to be stored as an array. And on the last 3 lines, you can see that there are built-in functions using the multivariate statistical summary object that allows you to get the mean, the variance, the number of non-zeros, et cetera, right? But again, we're able to parallelize this and run this at scale. All right, so let's move quickly on to Apache Kafka. I don't want to spend too much time on Kafka because I think a lot of people, especially today, know what Kafka is and understand where it fits into a big data architecture. I like to think of it as being similar to JMS or MQ, but it is not JMS or MQ. It has different semantics and it's far more scalable than those. But because of those different semantics, you need to code in a different way and design an architecture in a different way to use Apache Kafka to its full potential, right? So if we have a look at Kafka architecture, it has this concept of topics and partitions, and it has this concept of producers and consumers, and it uses something called Zookeeper. Well, newer versions of Kafka use something else aside from Zookeeper to do coordination between those topics and partitions, okay? And the most important thing to understand is that Kafka is an event streaming platform and not a message queue platform, right? And if we look at how Kafka fits into an overall architecture, you'll see that, for example, in the middle of the screen, in the blue box, you'll see Apache Spark in there. So Kafka and Spark can be used together, right? As well as other things like Apache Solar, which is a search engine type of project, as well as Storm, and other things like that, okay? So just to give you an idea where Kafka fits into this overall architecture. All right, let's go on to the next one. The next one I want to talk about is a little bit different than the first two or the other ones we'll talk about. It's called Apache Zeppelin. Now, Apache Zeppelin is a web notebook like Jupyter Notebook. It is written in Java, and it has plugins and libraries for many of the Apache big data projects. And you can use Apache Zeppelin to write different kinds of code or produce different kinds of graphs that allow you to do analysis in an interactive way. So it's not, Apache Zeppelin is not something that necessarily powers your big data projects. It's something that you use to build out or experiment with your big data projects. You can connect it to a Spark cluster locally or a massive one in the cloud. You can connect to JDBC to pull in data, and you can write code in it using Scala, Java, Kotlin, or Python, among other languages. Right, so let's have a look at what it actually looks like. So this is a Zeppelin notebook that is pulling in a data set and is essentially showing some graphs based on those data sets that you pulled in. And of course, in different paragraphs in Zeppelin, you can actually write code right inside of Zeppelin. And here's an example of using Scala to go and pull in some banking data and then to do some manipulation of that data, et cetera, et cetera. So I love using Zeppelin for doing some experimentation and even producing reports and doing some analysis of data that I have stored in either HDFS or in Apache Spark or wherever. Okay, so let's talk about the next one. This one you may not have heard of before. It's called Apachepino. And what Apachepino is, it's a real-time distributed OLAP data store. OLAP stands for Online Analytics Processing. And it allows you to do OLAP queries with low latency. And again, you may not have heard of Pino, but it's actually a really interesting big data project. It allows near real-time ingestion of data from Kafka as well as other sources. It lets you do very low latency queries against those, and those queries kind of look like SQL, right? Who's using Pino? So for example, if you ever go to LinkedIn and you see, click on the Who Viewed My Profile button, that is actually driven by Pino. So when you click on that, it's going out to a Pino cluster and it's asking, hey, who's viewed this user's profile? And it's able to get that information back in near real time. It can also be used for doing anomaly detection inside of large data sets. Another example of where someone is using Pino is that Uber Eats uses it for their restaurant analytics dashboard to get near real-time information out of a huge amount of data for restaurants to be able to see what orders are coming in or what orders have been filled and stuff like that. Okay, so just to give you an idea of all the different things you can do, you can ingest data from lots of different places, millions of events per second, for example, and you can use it in user-facing apps like LinkedIn and anomaly detection, or even in operational analytics. And there's a company called StarTree that provides more information on them. You can check out their YouTube channel for some beginner information on using Apachepino. All right, so let's move on and talk about Apache Beam for a second. Now, Apache Beam is, again, probably not a framework that you've heard of or used, but Beam stands for batch and stream. And what you do is you define and execute data processing pipelines. So for your big data projects, which require batching and streaming, or one or the other, you should check out Apache Beam. Right, so its use cases are for doing ETL, which of course you've heard that term before, for doing batch processing and for doing stream processing. And if we have a look at a diagram, right, what we have is we have Apache Beam in the middle, or the model of which in the middle, and Apache Beam also allows you to build out those runners, or that business logic, processing logic, in a variety of different languages. Of course, it's written in Java, and you can write your code in Java. And then once you've done that processing, you can go and have it move on in its next phase to, for example, into a Spark runner, or you can run stuff directly. And you have the flexibility to define how your data comes into your processing pipeline and how you want to batch it. And then you can have a number of different things like Apache Flink or Apache Spark go and actually execute that batch processing or that stream processing in the way that you would like to do. All right, so let's have a look at an example of a beam. All right, and what we're doing in this is similar to the Apache Spark example I showed before, where we're doing kind of like a word count. So in this case, what we're saying is go read on the third line, go read from a file, convert it into a flat map using a split on a space, lowercase everything, trim punctuation, apply some filtered stop words if you want to filter out some stop words. And then at the end, you'll see we do count dot per element, and this will count out all the different words or the occurrences of all the different words. And this is how you write a very, very basic Apache Beam project. In this case, we're just doing word count. Okay. And also, one of the nice things, as I mentioned before, is that a lot of these open source, especially Apache big data projects, work well together. So there's another project called Apache Airflow, which allows you to programmatically build, schedule, and monitor these workflows. And those workflows are in Beam. So it uses something called a DAG, or directed acyclic graph, that allows you to schedule them and build them out. There's also a way to do this using a user interface so that you can see which pipelines you have running, monitor their progress, see which ones failed in case you need to fix them. And the idea is that it's a slightly higher level environment compared to low level coding in Beam to be able to get a full view of your different batch processing or stream processing type of pipelines. Okay, and of course, there's a lot more to explore with all this big data universe. Some of the other ones that we didn't mention, for example, are Elastic, which has Elasticsearch, among other things. There's also Apache Druid, which is similar to Apachepino for doing real-time online analytics processing. And of course, we mentioned Spark, and we mentioned Hadoop, and we mentioned a few other tools that are very good at working with big data and building out the big data projects. Now, one of the main things to remember when you're building out these big data projects is how do you go and run them both locally and in the cloud. And big data projects generally tend to have quite a bit of different ways of configuring them and setting them up and stuff like that. But thankfully, There are good tutorials for all of these projects out there. The other thing that you should remember is that when you're running these big data projects, they are running on Java. And once you get them to a place where you have them running on production and you see that you need to start scaling out, you have to think about how are we going to scale this out, whether it's on your own infrastructure or in the cloud. So you have to do a little bit of planning up front after you've done some experimentation to figure out what kind of scale you need. For example, how many Apache Spark servers or nodes do I need? How much memory should I allocate to that Apache Spark cluster, among other things? And of course, once you get to a point where you're running these things and you want to get the most out of the big data project, whether it's Apache Kafka or Cassandra, or for example, Apache Kafka, you can run all of those things on this standard OpenJDK or whatever version of the JVM you like. But I would say that it's worth your time to look and see if you can get some benefit by running those projects on Azul Platform Prime, which is a high performance JVM that's specifically designed to be long running and with large heaps and give you lower garbage collection times, give you lower latency, and give you much more performance because of those two things. And actually, for example, for Apache Kafka, in our performance lab, we've seen that Azul Platform Prime gives you approximately 20% plus improvement in performance because of its lower latency and lower garbage collection times. So what you get is much more stability, as well as you get the ability to save on your cloud infrastructure. So if you think of that 20% performance savings, that means you can push your Apache Kafka cluster harder with less servers. So for example, if you're running, let's say 10 nodes in your Apache Kafka architecture, that means that you might be able to just run 8 nodes instead and save 15 to 20% on your cloud infrastructure bill. And typically Apache Kafka runs with 6 or 8 gigs of RAM and many processors. So it's not cheap to run this on today's cloud, whether you're running on AWS or whether you're running on Amazon or Microsoft Azure. Okay, so that brings us to the end of this presentation, and I'm happy to take any questions that you have on big data in Java or just big data in general. So I myself have played around quite a bit and have written production applications on Apache Spark, which is one of my favorite frameworks. So we have a question that says, I know one cannot pinpoint a size which separates big data from normal data, but what is the rough data amount to speak of big data? Many people have very different ideas when something is big data in projects or with customers. So this is a great question, right? And the way that I like to think about it is that if it's not even remotely possible for you to run on your high-end laptop at home, right? So I have a MacBook Pro here, which has, I think this has like 8 or 10 cores in it, or 12 cores, 8 cores in it, and 32 gigs of RAM. If I can run a project on this, that is not a big data project, right? It also only has 1 terabyte of storage on it. So it's not so much the storage as it is the speed at which you need to process the data, as well as the size of the data, right? And also how quickly is the data changing, i.e. the velocity. So if I flip back a few slides, I think I can explain this a little bit better by having this up here. How far back do we need to go? Okay. So basically these 3, volume, velocity, and variety. So if your data is only like 10 gig in size, not a big data project. 500 gig in size, possibly, but how quickly is that data changing, right? How fast do you need to do the processing on it? How many different types of data structures do you have? Are there relationships between those types of data? So for me, I think of big data that's more than 100 gigabytes of data. Something that requires you to do some even if it's simple processing, but something that would typically require a fair amount of compute power to do, and also that you may need to do in a small amount of time. However, that's not to say that you can't have a big data project that takes a long time to process. So for example, I was working with the customer a while back, and what they wanted to do was they wanted to take their pricing engine, which was normally running at, let's say, would take 3 hours to run, if I remember correctly, to produce essentially over 10 million different price points for the different variations of their product, if you will, that they have. Okay, and they wanted to take that down from 3 hours down to less than 20 minutes. So even at 3 hours, it was a big data project because of, they were producing 10 million different results out of it. So that alone, in terms of the volume of the data, is very large. But to get from the different input data to those 10 million results would require something on the order of over 5 or 10 billion calculations, right? So now we're talking about a big data project there, right? And their data had some nuances in it. And what they would do is they would generate this data and they would store it somewhere. And then when you went to their website to go get pricing information, it would have the data available instantly because they didn't have to do on-the-fly processing. But they wanted to, their business people wanted to continuously update their pricing models for this huge amount of data. So, okay. All right. Any more questions from folks in the audience? All right. I think we covered all these different things. But again, if you have more questions, please ask them in the chat. But when you get the slide deck and you want to dig in a bit deeper, all of the diagrams and the code data and stuff like that have links at the bottom so that you can follow up on those specific things like this one. And then if we go much further, let's go, let's just skip ahead a bit. Oh, looks like I stopped the share by mistake. But for example, if we look at the Apache Cassandra option here, if I can find the right thing, right? If we look at this Apache Cassandra slide right here, you'll see that at the bottom of this, there's a really nice tutorial for getting started with Cassandra. And then there is, for the Spark one, I have the links for where these code entries can be found, along with most of these have GitHub repositories that allow you to go and just download the code with a little bit of a recipe to go and run all these different types of things. So please have a look at the slide deck. And if you look at the different diagrams and screenshots which are in here, they have URLs that will show you where you can go to look at the examples that I'm showing. Okay. All right, any last minute questions before we wind up the session? Okay, well, great, everybody. Thank you for coming to this session. I hope you enjoyed it. And please, if you have any more questions, I'm more than happy to talk about your big data project or to talk about the content in this presentation specifically. You can reach out to me on Twitter at @PRPatel. I'd be happy to talk to you about the JVM or about big data projects or just Java in general, right? I'm a big Java nerd. You can see I'm wearing a JVM hat. So I appreciate you coming and thank you for your time.